So when we run a study, there's essentially four types of variables in any study. There's nominal, ordinal, interval, and ratio. Now these largely build onto one another. So a nominal variable, this is where there are discrete, meaning discrete means that you can't be in more than one and you can't be in the middle of these. There's discrete groups or categories. So an example of this would be your traditional research experiment. So an experimental study with a control group and an experimental group. And the reason that this would be a nominal independent variable is because you have a manipulation. You are either in this group or you are in this group. There's no sort of in between here, and it's not a continuous variable. This is a categorical variable with discrete groups or categories. Another important concept here is that there's no ordering to these. Now you might say that the experimental group is probably going to perform better or worse than the control group on whatever you're measuring. That's not what we mean by an order here. An order would be a very clear natural ordering to these groups. There's not a clear natural ordering when you look at experimental versus control. Another example of a nominal variable would be something like eye color. Right? There are groups to this variable. You might have brown eyes, you might have blue eyes, you might have green eyes, you might have, somewhere in between like hazel or something like this. But the reality is that these are discrete groups, right? You either have brown, green, blue, etc. And these are groups. There's not a natural order to these. Now, if you really think about it, yes, eye color is determined by melanin, and it's sort of the amount of melanin present in things like this. Well, we're kind of getting a little bit technical here with eye color, and yes, that could be more of a continuous variable, but how most people think about it and how most researchers might examine this variable would be in discrete groups. Another example might be race. So you belong to this race or this race or this race or this race, and that would be a categorical variable, and there is not a natural ordering to these groups. Now, you might bring up that in society, some groups are favored over others or have more advantages than other social groups. That is not what we are talking about here when we say ordering or a natural ordering. There is not a natural ordering of groups on the basis of race here, and that is why all of these would be examples of nominal variables. Jumping over here to ordinal, now it is still categorical, except now there are ordered categories. And you might be asking, what exactly does that mean here? Well, an example of an ordered category would be like metals in a race, right? So you might have gold, silver, bronze. Right now there are groups. You either get the gold medal or you get the silver medal or you get the bronze medal. But now there is a clear order. Gold did better than silver, did better than bronze. Let's also look at some other ordinal variables. So another ordinal type variable would be a Likert type scale. And the reason that this is ordinal, and if you're wondering, a Likert type scale is one of those that is like measured on a 1, strongly disagree, to, for example, a 7, strongly agree scale. And you might be saying, how do I actually answer this? Well, when you fill this in, it's a 1, and there's a bubble there that you could check. There's a 2, and there's a bubble. There's a 3 and a bubble, so on and so forth, all the way to 7, and there's a bubble underneath 7. And what's happening here is that you have this category or this category or this category all the way up to this category, and you're not answering in the middle. It's not like you would score a 1.5 here. It's that you are answering either a 1 or a 2 or a 3 or a 4 or a 5 or a 6 or a 7 on this particular scale. And there is now an order to it that 7 is higher than 6, is higher than 5, is higher than 4, so on and so forth. So a Likert type scale would be another example of these ordered categories. Absolutely here. Another example of an ordinal measure would be something like year in school, because there are discrete categories, meaning that you are a first year, a sophomore, a junior, or a senior, and there is an ordering to them that senior, you have been in school longer than a junior, has been in school longer than a sophomore, has been in school longer than a first year student. So again, ordered categories here. Now interval is now ordered, and the distance between each score is the exact same. So thinking about this, an example of an interval measure would be degrees Fahrenheit. So degrees Fahrenheit would be an example of an interval scale, because the distance between 25 and 26 degrees is the exact same as the distance between 55 and 56, or 60 and 61. And so these are ordered, meaning that as you go higher in this particular scale, it is getting warmer progressively, and the distance between each of those units is the exact same. Now, depending on how you're measuring it, it could be discrete, it could be continuous as well. Continuous meaning that people could score like 52.5, right? It could be discrete if you were just accepting answers that were whole numbers. So it could be a whole number like 55 degrees, or if you allowed for decimals, it could be a truly continuous measure there. Another example of an interval scale would be something like intelligence or IQ tests. So on an IQ test, you might score a 105, for example, but the distance between 104 and 105 is the exact same as the distance between 94 and 95, is the exact same as the distance between 120 and 121, and that's what makes this an interval unit of measurement here. Another example of an interval unit of measurement could be the calendar year, because the distance between 1980 and 1981 is the exact same as the distance between 2005 and 2006. And so calendar year would be, again, an example of an interval unit of measurement that you could measure as a discrete variable, meaning 1990 or 2006 or 1772. You know, it's discrete. You were 1 year or another. You could also measure this more as a continuous variable if you were looking at the year like, 1880 and 1880.5, right? Which would mean that you were halfway through 1880. Now let's look at some examples then of a ratio unit of measurement. A ratio is the same as interval, meaning that it's ordered, and the distance between each score is the exact same, but there is now a real zero. And what we mean by a real zero, because you might be, at this point, you might be freaking out and saying, Connor, there is a real zero in degrees Fahrenheit. There is a zero in calendar year AD, for example. And I should actually put AD there when we're looking at the calendar year AD. There is a zero, right? It's when the calendar year AD started. And degrees Fahrenheit, there is a 0 degrees Fahrenheit. But what we talk about in statistics and in psychology and in science more broadly when we're looking at types of variables, it's that the 0 is an absence of the thing. In degrees Fahrenheit, 0 is not an absence of temperature. Otherwise, we wouldn't be able to go into the negative temperatures. On the other hand, degrees in Kelvin, 0 is an absence of temperature. That is when the molecules stop moving. Degrees Kelvin is a ratio unit because now there is a real 0. Something like weight in pounds, for example, there is a real 0. It is the absence of any weight. Whereas degrees Fahrenheit, 0 does not mean an absence. Calendar year AD, yes, there is a 0 if you look back, but it is not an absence of time because there was time before AD. And so when we look at these variables, and you might say, like, what is the point of differentiating between interval and ratio here? Because they both seem to be functioning almost the same. Well, actually, they don't function the same based on what these are, because, you know, things like height, weight, time, all of these variables, and we could say time in seconds, we could say height in inches, we could say weight in pounds, right? All of these different things, the 0 being an absence actually provides us with a lot of extra information here. Is it true that 10 pounds is twice of 5 pounds? Yes. Is it true that 100 seconds is twice as long as 50 seconds, or that 200 seconds is twice as long as 100 seconds? The answer is yes. But degrees Fahrenheit, while the distance between 31 and 32 is the same as the distance between 74 and 75, 70 degrees Fahrenheit is not twice as hot as 35 degrees Fahrenheit. 50 degrees Fahrenheit is not twice as hot as 25 degrees Fahrenheit. You might not have ever thought of it like that, but the reality is that it isn't. When we look at calendar year AD, 2000 is not twice of 1000 because there existed time long before the calendar year AD. IQ. An IQ of 140 is not twice as intelligent as an IQ of 70. That's not how that works. But with degrees Kelvin, with weight, with height, with time, and other units of ratio, units of measurement, it is true that twice of that thing is actually twice of it. Now, there is a sticking point that some of you might have pointed out here when we have these Likert type scales. So I'm going to take, for example, and I'm going to draw in a full Likert type scale. Just for the purposes of this, we're going to just do a 1 to 5 scale. So let's say 1 might be, and then we've got 2, we've got 3, we've got 4, we've got 5, and there's a little bubble under each that you could select. Now, if you've been paying attention, you might be asking yourself, how is a Likert type scale here and not an interval measure? Well, there's actually a lot of debate about where Likert type scales should exist in these units of measurement. Objectively, they should go here, but in reality, we oftentimes place them here in this category when we're analyzing them from a statistics standpoint. The reality is that probably makes statisticians a little bit mad. But the reason that they are objectively ordinal, and you could debate this with other people, you could hear a lot of opinions on this, they are objectively ordinal even though we treat them as interval, and I'll talk about why. You might look at this and say, well, wouldn't this be interval because it's an ordered variable? It's an ordered variable. As you move from left to right here, you are getting progressively larger, right? It is getting higher. It's an ordered variable. And you might say, wait a second, isn't the distance here the same as the distance here? Well, we have to think about what these different categories represent. It's that this here might represent strongly disagree. 3 might represent neutral. 5 might represent strongly agree. And this might be something like slightly disagree. And that yes, participants are answering with a 1, a 2, a 3, a 4, and a 5, which is seemingly the same distance between each. But who is to say that the distance between strongly disagree and slightly disagree is the exact same as slightly disagree and neutral? We don't know that those are the exact same distance, and as a result, even though this seemingly appears to be an interval unit of measurement, and the reality is that when we analyze Likert type scales from a statistic standpoint, we do treat them as interval. But objectively, they are actually an ordinal unit of measurement because the distance between each of these categorical representations, we don't know that they are exactly the same distance between them. So what I would encourage all of you to do at this point is to try to come up with your own examples. Or you could even ask AI to come up with examples of each, and then you could kind of talk through and use and try to figure out what makes each of these nominal, ordinal, interval, and ratio on your own.